So this is lesson 2, truth and equations. So to start off, let's just get the notation and vocabulary out of the way. First things first, we have a new way of multiplying. So in the past, we've always said things like, if I want to have, get my pencil out here. If I want 2 times 3, I would write that as 2 times 3. But as we discussed in the last lesson, this gets confusing when we're working with variables, because if I say that I'm not dealing with 3, instead I'm dealing with x, you'd have 2 times x. Well, that gets confusing on what's the x and what's the multiplication sign. So instead, we came up with this thing where we said 2 dot x. And that's a perfectly fine way of showing multiplication. But in algebra, oftentimes what we do is we say, you know what, if I have a number next to a variable, I know it's going to mean multiplication, so I'm just going to write that as 2x, knowing that 2x is the exact same thing as 2 times x. Another example would be if I had 1/2 m. This is the exact same thing as 1/2 times m. Or if I had 5 times j, this would be the same thing as 5j. So that's basically, it's just getting used to seeing it in a new way. Now, when we write it this way, we come up with a new term. So when I have, let's go back to our 2x. I'm going to just get rid of some of this stuff up here. That looks a little bit neater. Okay, so let's go back to our 2x over here. So I'm going to say, if I have, I'm going to actually write this in a different color. If I have 2x, where I am multiplying a number times a variable, it has to be multiplication and it has to be a number and a variable. It can't be a number and a number, can't be a number and a variable. This number gets a special name because I'm multiplying it to my variable. This number becomes the coefficient. So in 2x, we would call 2 the coefficient and we would call x the variable. Now let's just give a couple of non-examples over here. So some non-examples. Some non-examples of this is if I were to have x plus 2. If I have x plus 2, this 2 is not a coefficient. It's not, because I'm adding it, I'm not multiplying it. This is actually called a constant, but we'll do that later. If I have an exponent, x squared, 2, this squared is not a coefficient. Once again, it has to be something that's multiplied. So if I go up here to my, over here to my, my expression 1/2 m, 1/2 is going to be my coefficient and m is going to be my variable. All right, let's clean that up again. Next is solution. So in mathematical, in algebra, we have solutions to equations. So let's go back to our problems that we were working yesterday. For instance, if I have, say, let's not work in red. Let's say that I have 2 and x, and I'm telling you that this is going to be equal to 12. We said yesterday that if I have this, I can see that if this entire length is 12 and that this length is 2, well then this length here, the main part of my box, my x, must be what's left after I take 2 away from 12. So x would be equal to 10. So x is a solution to the equation 2 plus x is equal to 12. x is equal to 10 is a solution. In that exact same way, you could say x is equal to 2 is not a solution, because 2 plus 2 does not equal 12. So 2 is not a solution. So I'm going to cross that out so we don't get confused. So 10 is a solution. 2 would not be a solution. A solution is just a value that will make an equation true. All right, so now that we've got the vocab out of the way, let's get to the content of the lesson. The first thing that we've got to make sure that we understand how to do is to tell if an equation is true or false. So, given the equation xy is equal to z, remember we just learned that means x times y is equal to z. Find two equations that make this equation true. Not two equations, I'm sorry. All right, that should be better. Given the equation xy is equal to z, find two solutions for x, y, and z that make this equation true and two solutions to make this false. All right, this should be solutions. So I'm going to start off over here. I'm going to say these are going to be my true solutions or true equations. And these are going to be my false equations. All right, so let's start off with a couple of values. If I wanted to make this true, let's say that I want x to be equal to 2 and y to be equal to 6. That would mean if I'm dealing with my equation x, y is equal to z, that I would have 2 times 6 is equal to, that means that z has to be 12. So this would make one true equation. Another one that I could do, number 2, is I could say if x is equal to 1/2 and y is equal to 24, well then, let's scoot this up a little bit. Then I would come up with the equation of if I have x, y is equal to z, then this would be 1/2 times 24, and I know that would give me that z would be equal to 12. So these would be two examples of when this equation was true. Now the false ones, these ones are kind of fun to make up. We're just looking at what would make this equation not true. What values could x, y, and z not be? So I'm going to say for number 1, let's say that x is equal to 100. We'll say that y is equal to 20. So that would mean that it would be 100 times, can't do that, times 20, and I'm going to say, well, what if z was equal to 5? Well, we know that 100 times 20 does not equal 5, so this would be a false equation. Another example of a false equation would be if x was equal to 4 and y was equal to 10. So we had the equation x, y is equal to z. We would have 4 times 10, and something that z could not be equal to then would be 1,000. So this would be a false equation.